Let's talk about resonance. So, example 2. Suppose let's say this time 1 kilogram block is connected to a spring with K equals to 9 newtons per meters. If an external force of F equals to, and usually you put cosine of something. So let's just put 4 times cosine of, let's put W for this one. This is W, not omega. Omega is round thing, and this is point. Is constantly being applied. So don't take this constantly as meaning constant. I mean, this is always present. That's what I'm trying to say. Find the general solution. And also the resonance frequency. Solution. What's the equation now? Oh, assume frictionless. Okay, assume no friction. Or else we don't know the value of C. Right? So if there's no friction, no damping, what's the equation now?
X.
M is what?
1.
1. So x double prime plus 9 x equals to
4 cosine.
4 cosine omega t, W t. So we have this. We're trying to solve this. First, you have to find the complementary solution, right? So that says x complementary is equal to C1 cosine omega t. No, not omega t. We know the value of omega here. What goes in here? 3. Plus C2 sine 3t. That's the complement. All right, now we have to find a particular solution. In order to create this on the right, what should you have?
Cosine WT.
You need a cosine WT. I keep writing omega. Maybe you're not going to see the difference, but I need a pointed one. Omega t.
Why don't you just use X? No?
X? No, you already have X here.
What about
I
G?
guess I can use A or B or
What
something
about
like that.
Q?
What else do I need?
Sine.
Sine.
WT.
So I need one for cosine, another one for sine.
you grade the quizzes?
Okay. You differentiate this. You get A omega, AW, sine WT with the minus, plus AW cosine, not the A, sorry, it's B, BW cosine WT. Differentiating one more time gives you negative AW squared cosine WT minus BW squared sine WT. And then if I plug all these in to the left side to match with the right side, this is what we're getting. So I get xp double prime plus 9 times xp equal to 9 minus a w squared cosine wt, and then, sorry, not 9, that's not right. I get 9a minus a w squared, okay, and minus 9b, actually, plus 9b, yeah, 9b minus bw squared sine wt.
So what are you doing when you make that line, the last line? What happened? You just
This became this became this. I added them. So in other words, just multiply 9 to this.
Okay. Oh, you added that to the.
I added to this one, and that's what I get. And this has to equal to what?
4 cosine WT.
And because that's the right side. This is what we call the method of undetermined coefficients, right? You just plug it into the left side to match with the right. Okay? So that tells us that 9a minus aw squared should be 4. So if I factor this by a, we see that a must be 4 over 9 minus w squared. Whereas 9b minus bw squared should be
0.
0 because there's no sine at all, right? There's only cosine, so this must be 0. And if I factor the b out and divide, I get b equal to 0. So a must be 4 over 9 minus omega squared, and b should be 0. And then you see that xp is equal to 4 over 9 minus w squared times cosine wt. This is one specific solution, one particular solution. And the general solution is what? The complementary plus the particular. So C1 cosine 3t plus C2 sine 3t plus 4 over 9 minus w squared cosine wt. So that's the general solution. Now when does this general solution fail? When is this not the solution?
When omega equals 3.
Yeah, when w is equal to 3.
Yeah.
Right, yeah. Then this makes no sense whatever, right? Why? Because you're going to get 0. So that case has to be done separately. So this is when W is not equals to 3. So this is part of the answer. When W is equal to 3, what do you do? Do you want to go back and see?
Wait, how did you get the XP again?
Oh, XP is, I got the value of A and B, right?
Yeah.
And I had XP as this thing. So A is that thing 4 over 9 minus W squared. B is 0. So after plugging that in, I get the value of XP.
Oh.
Alright. Okay, so going back, if W is 3, we have to do something completely different. What?
Add X.
In this case, it's a function of t, so we have to add a t. Not add a t, multiply a t. Right? Yeah. So if W is 3, what goes wrong? Then our particular will have cosine 3t, which is duplicated in here. Sine 3t, which is also duplicated here. Okay? So what must be done? We have to multiply by t to both of them. Okay? We have to avoid duplication that way. Right? So that's a whole different calculation. Right? So this is a case when W is not equal to 3. But when W is 3, then we have to go back and say x of p is a times t times cosine 3t plus b times t times sine 3t. And then we have to differentiate this twice and plug it back in. It's a little painful, but let's do it. xp prime is a times cosine 3t plus, actually minus 3at sine 3t. That's just the derivative of the first one because I'm using the product rule. For the second one, if I use the product rule, b times sine 3t, and then if I differentiate sine 3t, it's 3bt cosine 3t. And then differentiating this yet again, xp double prime gives you the derivative of this, which is negative 3a sine 3t. And then this one I need the product rule again, negative 3a sine 3t. And then minus 9at cosine 3t, just from this one. And this one will again create plus 3b cosine 3t, and then plus 3b cosine 3t, and then minus 9b t sine 3t. All right. So after calculating this, I have to plug into the left side. What's the differential equation that we were playing with? X double prime plus 9xp. So this thing plus 9 times this thing. And if you look, you see that this multiplied by 9, that multiplied by 9, when added to this, it's going to cancel. It's going to cancel. 9 times this one plus that will cancel. 9 times this one plus that will cancel. And these two are the same, these two are the same. So at the end of the day, what you end up with is negative 6a sine 3t plus 6b cosine 3t. And what is this supposed to equal to? What is it supposed to equal to?
4 cosine.
4 cosine 3t. Because w is 3, and the right side is 4 cosine wt. So that immediately says A is
0.
B is
4 cosine.
6b is 4, right?
There.
Since 6b is 4, b is 4 over 6, which is 2/3. And therefore, plugging this back into the original xp, this was your xp, right? A is 0, xp is that, so we get xp as 2/3 t times sine 3t. And that gives us the general solution. X general is c1 times cosine 3t plus c2 times sine 3t plus 2/3 t sine 3t. So that's the case when w is 3. Now, what's the amplitude of this function? You can think of it like 2/3 t times sine 3t, right? So what's happening to the amplitude?
Changing.
It's changing. The amplitude is changing. Is the amplitude going up or down? It's increasing, right? So if you drew the graph of this thing, you're going to see something like this. Here's the y goes to 2/3 t, and here's y goes to negative 2/3 t. And the graph will be like, just like that, okay? So when it's just going up, fluctuating more wildly and wildly as time goes, what do you call such a thing? Resonance. Okay? That's how you can use acoustic waves to break down bridges, right? Supposedly. I don't know if it's possible. Can you? So you think of this natural swing of the bridge. If you know the frequency, then you can use some kind of resonance wave to make the resonance go higher and higher, and then at some point the bridges just swing wildly. Yeah. So a long time ago, when some soldiers were crossing the bridge, they were marching at a cadence, and unfortunately what happened was that the cadence frequency matched with the natural frequency of the bridge. So when they were just marching and marching, it caused resonance and was swinging wildly and more wildly, and the bridge broke, and all the soldiers fell down to the river. And after that, what they do nowadays is that whenever they're crossing the bridge, they call out of cadence. So you can't go in cadence on the bridge. So they call off the cadence, they freely march over the bridge, and only after crossing the bridge, they actually go back into cadence. So that's what you see. So as the answer, this will be the answer. I don't want to copy this all over again, but there are two answers. This is one general answer, which is the case when w is not equal to 3. And this is the answer when w is 3. And what's the resonance frequency in this case?
2/3.
No. 3. 3 is the resonance frequency. Okay? Yeah. When your external forces frequency matches with the natural frequency, then it causes resonance.
So did the first answer not have resonance in it?
The first one is the case when you don't have the resonance. If you don't have the resonance, they always, you can see that when w is getting closer and closer to 3, this value is huge, right? So already, if you're pretty close to the resonance, the swings are pretty high. But it's not increasing, it's finite. It doesn't increase to infinity, it's finite, right? But when you get the resonance, then you suddenly have a term where the amplitude is growing without bound. So this is what can cause a lot of